One of the most exciting developments in the last year was the introduction of the data channel modifier, which allows us to extract information from a mesh, process it, and output it to perform work. And in this case, we can use the data channel modifier to achieve the effect of a patina on a sculpture. We can find the curvature on the mesh, use that to drive vertex color in a shading network. And one advantage of doing this is that we can change the topology of the mesh, and that information will flow through our shading network in a way that would not be possible with a traditional UV-based mapping approach. Let's apply the data channel modifier. I'll select the sculpture, go to the Modify panel, and from the modifier list, scroll down a bit and choose Data Channel. Let's expand the command panel to take in more of the parameters at once. Hover the mouse over the border with the viewport until you see a left and right facing arrow cursor. Click and drag to extend the command panel horizontally, and you can stop when you see two columns. We've got the parameters here for the selected data channel modifier. Currently, its operator stack is empty. This is where we can layer effects in the modifier, similar to the way we can layer modifiers here in the stack. The operator stack requires at least one input and output operator. Let's add an input operator first. Click on Add Operator, and in the Add Operators dialog, under Input Operators, we've got Curvature. And note that it has a sub-object vertex icon next to it, indicating that we'll be operating on the vertices of the mesh. Select Curvature and click Add Operator at the bottom of the pop-up dialog. And we can close the Add Operators dialog. Now we've got a single operator in our stack, and we've also got a preview display in the main view. We can turn that on and off from this Enable Display button. We can also access the display properties. So let's open up this rollout. And this tells me that the values from the curvature operator are being mapped onto these colors. A low value for curvature will give us a blue color, mid-range value green, and a high value red. And that is controlled from the curvature parameters here. We can access those if the curvature operator is selected. So if it's not selected, then we won't have access to these. I'll scroll down a little bit. The curvature properties are convex, flat, and concave. And most importantly, at the bottom is a scale value, which will exaggerate the effect. Let's do that first. I'll set the scale value to 4 and press Enter. And now it's a lot clearer what's going on here. Convex are the areas such as the bridge of the nose. And then flat are, of course, the flat areas, such as the cheek. And concave corresponds to these recessed areas, such as at the bridge of the nose and inside the ear. And we can adjust the mapping based upon those curvature parameters. I know in advance that my vertex colors are going to need to be inverted to work properly. I can accomplish that using these parameters here. For example, I can set the convex value to 2 and the concave value to 0. And I've essentially flipped the color scheme now, and I've also exaggerated the blue in these concave areas. So concave, which are the recessed areas, is yielding a low value, which is mapping to blue. And convex, which are areas on the bridge of the nose, etc., that's now yielding a high value, which is being mapped onto red. Okay, so I've inverted the values and also exaggerated them. And finally, I can change the contrast using the flat parameter. Small adjustments to the value of the flat parameter will have a profound effect on the contrast. I'll set flat to a value of 0.45 and press Enter. Now the preview is showing me basically what I want to achieve for this sculptural patina effect. And the areas we see here in red will be the most worn or shiniest and most yellow. And then the areas in green will have a kind of a dark brown, and we'll have a dark green here in the most concave or recessed areas. In order to apply these values in a shading network, we also need an output operator. Go back to the operator stack, click Add Operator once again, and scroll down to the output operators. Choose Vertex Output. Then click Add Operator. And we can see something strange at first in our view. The model is now squashed horizontally. And that's because the default type of output is position. What's happening is the position in X of each vertex is being controlled by the curvature. Change that position pull-down list to vertex color. And below vertex color is a pull-down list from which we can choose X, Y, or Z. And we want to leave that at X. What that's going to do is it's going to send the curvature to the red channel of the vertex color map. Okay, so we're leaving that at X, which is red. And finally, we can clean this up a little bit because my mesh is kind of low fidelity and we see some artifacting where we have less resolution or detail in the mesh. Let's just smooth this out a little bit. Back in the operator stack, once again, click Add Operator. And in Process Operators, choose Smooth and click Add Operator. Close the Add Operators dialog. The Smooth operator appears at the bottom now. I just want to click and drag that and drop it in between the curvature and the vertex output. And with that Smooth operator selected, we can access its parameters. We can see how much smoother our vertex shading is now. Let's just increase this value a bit. I'll set the iterations to 8 and the amount or intensity of the effect to 0.5. And now we've got a very soft effect. Excellent. So I can turn the display off, click Enable Display, and we're ready now to use this information in a shading network. Open up the material editor. I've already prepared a material and 2 gradient ramps. Let's connect the diffuse gradient to the base color and the roughness gradient to the roughness map. We can double click on the diffuse gradient label and see its parameters in the parameter editor on the right. And these are the 3 colors of the diffuse. Likewise with roughness, I can double click on its name. And here's the roughness map. And that roughness, of course, determines the shininess of the physical material. So in some areas of curvature, it will be shinier than others. We can connect our vertex map now. That's going to be found, of course, in the Material Map browser, in the Maps section, under General. Scroll down, and here's vertex color. Drag that over. Connect it to the source map input for both of these gradient ramps. And the same for the roughness gradient. We want to connect to the source map input port. And as long as each one of these is using the gradient type of mapped, then whatever value is coming into this source map is going to determine the position along this gradient ramp. All right, so those connections are made. We also need to double click on vertex color and change the sub-channel over here to red. Remember that we're only using the red channel of the vertex colors. As soon as we do that, now these gradient ramps have some preview swatches. Very cool, so we can close the material editor. If you see some render error messages, don't worry about that. That's fine. You can close the render message dialog. And we'll do a production render in Arnold. Just click on the teapot with a lightning bolt. And here's the result of our shading effect using vertex color derived from the curvature extracted in a data channel modifier.